I'd like to welcome everyone to our first talk this fall in the program in Creativity and Consciousness Studies. And we're very excited to welcome Professor Avi Loeb from Harvard University. My name's Ed Sareth. I'm a professor of music and founder of the PCCS and co-director, along with my colleague, Molly Beauregard. We've been excited to be working on this series of talks, thanks to funding from Tuning the Student Mind. We kind of pride ourselves in stretching the boundaries of typical academic discourse. And this tonight we may actually be stretching the boundaries of the boundaries. We built up quite a nice email list, and typically when we send out the notice, there's, as usual, there's requests to unsubscribe. That's just the case with all kinds of email lists. On this one, I think we set the record in terms of requests to unsubscribe, some very colorful. So for those of you that have showed up, we congratulate you for your visionary vitality. And but we're really happy to have Professor Loeb, who is, I'm assuming people have read his biography. I'm not going to go through that. That would probably take up half of the session. But we're really talking about a major figure, a virtual who's who in the field of, I mean, it would say not just astrophysics and astronomy, but science in general. I mean, he's written 8 books, including a bestseller. I highly recommend his most recent book called Extraterrestrial. And he's, by the way, I included in the link a link to his a series of essays that it seems to be replenished every few days. It's pretty amazing. Dr. Loeb has almost 1,000 papers published, and so we're talking about a really exciting figure. And just a personal reflection on why I think this is significant. I happen to have been interested in this topic probably going back to middle school, and I mean, I don't think anybody would disagree that this is an exciting topic. But there's kind of maybe even a broader question, and this is where Professor Loeb, I think, is particularly eloquent in just placing front and center the questions that the topic raises about the nature of the human being, the nature of human potential, our place in the cosmos. And so one of my favorite aspects of his writing is just when he gets us to stop and recognize how often in the academy we constrain our inquiry into very narrow horizons. So without further remarks from my part, thanks so much for Professor Loeb for joining us, and we're thrilled to have you.
Thank you. Thank you for inviting me. It's a great pleasure to join you remotely. I hope one day we'll meet in person. Let me share my screen. I just wanted to mention that as of yesterday, I have the cover of my next book. It should come out in June 2023. And you look at it right now, you're looking at it. The title is Interstellar, and it actually focuses on the implications for humanity from what I'll describe in a few minutes. So let me get to my presentation. And before that, I'll show you a short video that was produced by NBC. So let me just make it, oops, no. One second. Okay.
My name is Avi Loeb, professor of science at Harvard University. In the coming months, I'm going to lead an expedition to Papua New Guinea to scoop the ocean floor and search for fragments from the first interstellar meteor.
Although Avi is in search of what he believes may be alien technology, proof of extraterrestrial existence has never been what's driven his life's work. Until now.
I'm hopeful we will find something. The question is, what is it? An unusual rock, a natural object, or artificial?
Despite being the longest serving chair of Harvard University's Department of Astronomy, it wasn't until recently that he started to investigate the possibility that there is life beyond our solar system.
I found a catalog that the government compiled of meteors that were detected by government sensors that are missile warning system. I asked my students to check if any of the meteors, the fastest moving meteors, could have arrived to Earth from outside the solar system.
There was one in particular that sparked the interest of Loeb and his students, Amir Siraj.
We decided to write a paper about this meteor, which was discovered on January 8, 2014. Light from the explosion was seen by government sensors.
Despite the government releasing limited data, he had discovered something groundbreaking. His paper laid out what he believed to be true. But 3 years after writing his findings, a major development confirmed what he knew all along.
After a few years, the release of a letter from the US Space Command in the Department of Defense stating explicitly that this meteor at the 99.999% confidence level came from outside the solar system.
Based on the speed of the meteor and how much of the object burned upon entry, Avi determined that it must be made of a material that is tougher than iron.
And so this one was an outlier in terms of its composition. It was also an outlier in terms of its speed outside the solar system. It moved at least twice as fast as stars move relative to the sun in the vicinity of the sun.
Armed with new evidence validating his findings, Avi decided to take action and make moves to recover the object, his next hurdle. Funding through private donations, he has secured a portion of the money to take the trip.
Let's continue to look for objects like it. It was obvious to us that we need to go there and collect the fragments, because to do the same thing for an object in space would cost more than $1 billion. For a cost that is 1,000 times lower, we can go to the ocean floor and collect material from an interstellar object.
Now, Avi has the task of finding an object that most likely fractured on impact, leaving fragments possibly the size of pennies lost at the bottom of the ocean. It's a challenge that might seem insurmountable in the vast existence of the Pacific Ocean. But Avi is confident they will recover what they are in search of.
It's a fishing expedition, literally speaking, and what we can do is basically take the trajectory of this meteor and extrapolate it all the way to the ocean surface. Now, of course, when the explosion took place, there were fragments generated and they were scattered over a region. One imagines that the tiny pellets would be carried farther away from the point of impact, whereas the heavier fragments will sink down closer to the impact. Finding a big chunk can inform us much more about the structure of the original object. We're planning to board the ship and build a sled and a magnet attached to it that will scoop the ocean floor, and we will go back and forth like mowing the lawns across the region 10 kilometers in size and collect with the magnet all the fragments that are attracted to it, and then brush them off and study their composition in the laboratory. This will be the first time that humans put their hands on the material that makes an object that came from another star.
With more advanced technology in our skies than at any other point in history, new findings are becoming far more frequent and impossible to ignore. Thanks to a government report that was released last year, the possibility of extraterrestrial life and the pursuit of proof of its existence is finally losing its stigma.
The stigma has been reduced. Would be the most important scientific discovery that humanity ever made, because if you think about it, we change our perspective about our place in the universe.
With science in its corner, this professor is not intimidated by critics.
It's not a philosophical question whether we live in an environment where objects are floating around that are representing extraterrestrial technologies. We just need to use our telescopes and find out. In fact, we are not even the first to say that. Galileo Galilei said that 4 centuries ago, and he was put in house arrest. Today, he would have been cancelled on social media. Once I realized that we found an object from a technological origin that was produced elsewhere, I would not seek approval from anyone else. I don't need likes on Twitter. I just want to know what it is.
Okay, so that was a video produced by NBC. Let me now get to my talk. And I will get to this subject. So what I'll describe mostly is content from my book, Extraterrestrial, that you see in the middle here. And if I had to summarize it in one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. And what you see on the left is a photograph of a picture hung on the walls of the Berlin Brandenburg Academy of Science and Humanities. In fact, now it shows also at MIT and Japan. It's from an exhibit by the German photographer Herlinde Quilbel, who came to my office a few years ago and asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" And actually, this question is not just for scientists. It turns out that anyone interested in spirituality cares about it. And the evidence I have for that is an email I received just a few weeks ago from a rabbi who gave a sermon for Yom Kippur, the Jewish holiday, last month. And she wrote this sermon, you can see it on the right-hand side, inspired by my book, Extraterrestrial. And so I wrote a post on Medium that you can see on the left related to that sermon. The bottom line is that the exploration of the frontiers of science have something in common with spirituality, because in both cases, we are exploring the unknown. And speaking about that, a year ago, I established the Galileo project, and I'll talk about the three branches of the Galileo project, one of which you heard about just in the short clip that we looked at, but there are two other ones. And we had a conference, the first in-person conference of the Galileo project at the beginning of August. So I'll just show you the beginning of a short video.
It's such a great privilege and pleasure to see 70 members of the Galileo project team coming together, celebrating the past year accomplishments of the project. And we're just at the beginning, because in the coming year, we hope to collect data and find out what it shows. We make no assumptions, we're completely agnostic, but it seems like the government is telling us that there are some exciting objects out there that we need to figure out what they are. And that's our hope.
Okay, so let's let me move on. Oops. So what does the scientific method teach us? Well, we now know something that Carl Sagan didn't know, and that is that a substantial fraction, somewhere between 3% and 100% of all sun-like stars host an Earth-sized planet roughly at the same separation. So what we find in our backyard, the Earth-Sun system, is not unusual. We are not privileged the way we thought. We thought that we are at the center of the universe, and now we realize not only we are not at the center of the universe, but actually what we see around us is quite common. And altogether, there are more habitable Earth-like planets in the observable volume of the universe than there are grains of sand on all beaches on Earth. So that brings a sense of cosmic modesty. And when you look at emperors or kings that used to be very proud of themselves after conquering a piece of land, and nowadays we have Putin trying to conquer a piece of land, that doesn't look very impressive, because it's just like an ant trying to hug a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from, because when my two daughters were very young, they thought that they're at the center of the world. And the smartest, because they compare themselves to the family members. And of course, that changed when on the first day in the kindergarten. So when will we find that there might be a smarter kid on our cosmic block? Well, we will mature, our civilization will mature by finding others. And my point is that Albert Einstein was not the smartest scientist who ever lived since the Big Bang. 13.8 billion years ago. This is a cartoon that you see in the middle of this slide that was drawn on the day that Einstein died. And it shows the Earth with a plaque on it stating Albert Einstein lived here. But in fact, it's very likely that there were smarter scientists on an exoplanet that lived 1 billion years ago. And the civilization that benefited from their wisdom had enough time to launch probes that by now would fill up the entire Milky Way galaxy, even if they are propelled by chemical fuel, the way we propelled all of our spacecrafts. And another important fact about the universe is that most stars formed about 10 billion years ago. The sun is only 4.6 billion years old. And so most stars are billions of years ahead of the sun, so to speak. And, you know, we have only 1 billion years left before the sun will boil off all the oceans on Earth. So if you think about most of the sun-like stars, they are ahead of us, and therefore there is no more life on their surface, because they are now, in terms of their intrinsic clock, they are beyond the billion years from now for us. So, you know, it may not make sense to look for radio signals. On the other hand, we might look for a letter in our mailbox, because if a substantial fraction of these stars have a habitable Earth-like planet, they could have sent probes into space, just like we send our interstellar probes. And if these systems target interstellar distances, there is no sense for them to wait for guidance from the senders. It makes much more sense for them to have artificial intelligence. I call these AI astronauts. And the question of whether such systems reached us by now is not a philosophical question. It takes about 500 million years to traverse the entire Milky Way galaxy at the characteristic speed of chemical rockets. So if they were sent 1 billion years ago, they had enough time to self-replicate by now. And the only way to find out whether we live in such a reality is to look through our telescopes. We shouldn't repeat the mistake made by philosophers during the days of Galileo, who knew the answer in advance and refused to look through his telescope. So what do we see from outside the solar system? Well, the first object reported was in 2017 by a telescope in Maui, Hawaii, called Pan-STARRS, that identified a near-Earth object that moved very fast, too fast to be bound to the sun, and therefore it must have arrived into the solar system from interstellar space. It was named Oumuamua, which means a scout in the Hawaiian language, and it was roughly the size of a football field. So at first, astronomers thought, oh, maybe it's just a rock from another star. But as I will describe, it had very anomalous properties. But it was not the first object discovered by humans from outside the solar system. It turns out back in 2019, I asked my student, Amir Siraj, to look through a catalog that the US government compiled of meteors, 273 of them, and to check for the fastest moving meteors. Perhaps one of them came from outside the solar system. And we found one that was spotted on January 8th, 2014, and it moved at 45 kilometers per second when it burned up in the Earth's lower atmosphere. So we wrote a scientific paper stating the case that it came from interstellar space, and it was actually the first interstellar object. It was roughly 0.5 meter in size, much smaller by a factor of 200 than Oumuamua, but we could see it because it exploded in the Earth's atmosphere as a result of the friction with air. The paper was not accepted for publication. It was declined in the Astrophysical Journal because the reviewers argued, we don't believe the US government. So then it took a few years, and in March 2022, this year, the US government issued the letter that you see on the left, where they confirmed the interstellar origin of this meteor at the 99.999% confidence. So now our paper is accepted for publication. And moreover, the government released data on the explosion, the light that came from the explosion, from the fireball, and that allowed us to make the case that the material strength of this meteor was tougher than iron. In fact, it was the toughest object in the entire catalog out of 273 objects. This was the first interstellar object and the toughest among all the space rocks that were identified. And that meant that it's an outlier. Then just a month ago, we found a second interstellar meteor in the same catalog, also moving very fast. And it was also the toughest, the second in toughness in this catalog. So drawing the two interstellar meteors out of the distribution of space rocks from the solar system has a likelihood of 1 in 10,000. And that means that whatever origin these meteors have, it's not a planetary system like the solar system. It could be natural, an exploding star that somehow sends out bullets that are much tougher than iron, or it could be artificial in origin, perhaps a spacecraft that is not functional anymore. Just think about a Voyager crashing into an exoplanet in 1 billion years. It will not be functional. It would look like a meteor. So we are planning an expedition. The fragments from this explosion landed about 100 miles off the coast of Papua New Guinea. And so I received funding from donors after announcing this mission at $1.5 million. We have the full funding, and we have a team of the best researchers in the world that are engaged in expeditions of this type. We'll use a sled with a magnet and scoop the ocean floor for the fragments from this meteor, simply checking the composition. What is it made of? Is it an iron meteorite, or is it something that is made of an alloy, like stainless steel, for example? And that would indicate that it's artificial in origin. One thing I did was promise the curator of the Museum of Modern Art in New York City that if we find a gadget, I will put it there on display. For us, it would represent modernity. For whoever sent it, it's ancient history. What you heard is the sound of the universe knocking on our door. That was the seismometer signal recorded when this meteor exploded. And the answer to Fermi's paradox, where is everybody, is check the front door. So we hope to do this expedition in about 6 months. But let me come back to Oumuamua, which triggered my interest in interstellar objects because it was the first one reported. The other two, the two meteors, were unusual in material strength, but Oumuamua was unusual in many other aspects. First of all, it came from a special frame of reference called the local standard of rest. That's the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And only 1 in 500 stars is so much at rest as Oumuamua was in that frame. So think of it as a buoy sitting at rest on the surface of the ocean, and the solar system bumped into it like a giant ship and gave it a kick through the gravitational influence of the sun. As the object was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that the surface area projected on the sky of the object changed by a factor of 10, and that's a very extreme shape. Usually for asteroids, we see a change by a factor of a few at most. But moreover, the variation in reflected sunlight was most consistent at the 90% confidence with a pancake-shaped object, a flat disc-shaped object. There was a paper written just about that. And the most unusual fact about this object was that it showed no cometary tail, no dust or gas around it, but yet there was an excess push that it exhibited away from the sun with a force that declined inversely with distance squared. And the simplest explanation for that would be cometary evaporation. But the Spitzer Space Telescope looked very deeply around this object, and you can see the image on the top right. It's basically just noise. There were no carbon-based molecules, the very significant limit. So this is clearly not a comet of the type that we are familiar with. And the only explanation that I could think of for the excess push away from the sun was if this object was pushed by reflecting sunlight. And for that, the object had to be very thin, sort of like a sail, and nature doesn't make such objects. So I suggested maybe it is artificial in origin. Now, what were the suggestions by mainstream astronomers to the anomalies of Oumuamua? Well, there was a suggestion maybe it's a dust bunny, a cloud of dust particles that is very loosely bound, so it's 100 times less dense than air, and sort of like a feather, it's being pushed by reflecting sunlight. And the problem with a cloud that is 100 times less dense than air is that it would not maintain its integrity when it comes close to the sun and gets heated by hundreds of degrees. And so another suggestion was maybe it's a chunk of frozen hydrogen, so that when hydrogen evaporates, we don't see it because hydrogen is transparent. We've never seen a chunk of frozen hydrogen. We don't know if molecular clouds produce it. And moreover, such an object would evaporate very quickly as a result of absorbing sunlight, starlight, by going in interstellar space. And it wouldn't survive the journey. We wrote a paper about it, and the authors of this proposal agreed. So then another team suggested maybe it's a nitrogen iceberg that was chipped off the surface of a Pluto-like planet, an exopluto. But then we calculated how much solid nitrogen exists on the surfaces of all the exoplutos that we can imagine, and imagine chipping them off. That wouldn't produce enough objects to explain one of them in the survey of the Pan-STARRS telescope. So there is a mass budget problem for this. But forgetting about the difficulties of these explanations, the fundamental question is whether Oumuamua was artificial or natural in origin. And the way I think about it is if you go on the beach, you very often see rocks or seashells that were naturally produced. But every now and then you might see a plastic bottle that indicates that the civilization is not very far. And that may be Oumuamua. Now, 3 years later, the same telescope in Hawaii discovered another object that shared the same qualities as Oumuamua. It was in September 2020, so this object was called 2020 SO. And then the astronomers who discovered it realized it actually, if you extrapolate the trajectory back in time, it came from Earth. It was a rocket booster that was launched from Earth in 1966 by NASA as part of a lunar lander mission. And so it reflected sunlight, and as a result of that was pushed away from the sun because it had thin walls. And obviously it didn't show a cometary tail because it was made of stainless steel. So we know that this object was artificial because NASA made it. Question is, who made Oumuamua? And if you imagine a cave dweller finding a cell phone, the cave dweller is used to finding rocks. So he would argue the cell phone is a rock of a type that I've never seen before. Just like Oumuamua is a rock of a type that we've never seen before. But obviously, if he's curious enough, he might press a button and realize that it records his voice, that the cell phone is not a rock. I should say that the discovery of Oumuamua as the first interstellar object inspired a winery in Santa Cruz to develop this brand of wine that this is the Bonnie Doon Vineyard. And in fact, we drank it at the banquet of the Galileo Project meeting. and they had a press release from the winery. And let me show you another place where the object was mentioned.
Lead at 4,400. How much would you like to waive? Let's do 2,000, please. Here's your clue. I look at the world and I notice it's turning, thanks to this man who studied at the University of Krakow in the 1490s. Who is Brahe? No, correct response. Who is Nicholas Copernicus? You lose a little bit. Pick again, Robin. Scientist for 600. We think of this Russian who became a professor of general chemistry in 1867 periodically. Robin. Who is Mendeleev? Yes. Scientist for 800. Avi Loeb thinks a space object seen in 2017 and artistically depicted here comes from this 16-letter type of being, the title of his book. Kevin.
What is extraterrestrial?
Correct.
Scientist for.
Okay. And I should say, I'm not sure, but I was told that the person who sent this email is on this Zoom call, and I very much hope that he is a rabbi from Ann Arbor, and he wrote to me a year ago and mentioned again a sermon given on this subject. So apparently, the context is of great interest, even to anyone focused on spirituality. And a colleague of mine said, the next time we meet for dinner, my wife and I would ask you to give a sermon, to which I replied, I would never lead a congregation whose members agree with me. So there is a new frontier in astronomy, and the first three interstellar objects, the two meteors that I mentioned and Oumuamua, appear to be quite unusual, outliers relative to the rocks that we have found from the solar system before. Obviously, to find our neighbors, we need to look through the windows and not just ask, where is everybody? Because Enrico Fermi didn't really have a telescope at his disposal of the type that we're using now to survey the sky. But there is also another context to this, and that is the government, the US government, talking about objects they cannot identify. And that comes from the Director of National Intelligence that delivered a report in June 2021. And actually, in a few days, by next Monday, there should be a new report delivered to the US Congress. The first report led to the establishment of a new office in government, and this office will actually collect data from all sections of government. Already started collecting data. I met with the director. He came to my home just a couple of weeks ago. We will see what the second report says in a few days. But basically, the government is finding objects in the Earth's atmosphere that they cannot identify. And that's another branch of the Galileo project. And the goal is to find what are these objects. And I'll describe in a few minutes the instruments we're planning to use. But just to explain the context, when you look for physical objects, you cannot really use the famous Drake equation that was written by Frank Drake, who passed away a couple of months ago, because you're not asking the question of who is around the Milky Way galaxy right now in terms of intelligent civilizations. You just ask for all the equipment that was launched by anyone who ever launched spacecraft into the Milky Way. So the number of objects we find is basically the number per unit volume times the volume of the survey that we are conducting. And if you use the Earth as a fishing net, then the speed of the objects also matters. But altogether, these properties, the number of objects per unit volume and their speed, would depend on their size, because NASA sent many more small spacecraft than large spacecraft. And of course, we should keep in mind that there is the ostrich factor. I mean, if we don't look, we will never find anything. So that has been the case until recently. We haven't really searched. Only over the past decade, we started finding some objects of interest. So we have a robot, the Perseverance rover, on the surface of Mars. It's looking for signs of early life on Mars. That will be no threat to human intelligence. We would still feel superior, even if early life existed on Mars in the form of non-intelligent microbes. But just imagine the same rover bumping into the wreckage of an advanced spaceship that represents technologies that we don't possess. That would be a blow to our ego. So a lot of people will feel offended by such a finding. But to figure out the nature of interstellar objects, we just need a high-resolution image of them. I would much rather show a photo album of Oumuamua than write my book. They say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. And I would be much happier with a high-resolution image of the type that OSIRIS-REx took, as you can see on the right side, of the asteroid Bennu when it landed on it. And it will bring a sample from this asteroid. You can clearly see that it's made of rock. So if this kind of an image existed for Oumuamua, we could have figured out whether it's a nitrogen iceberg, a hydrogen iceberg, a dust bunny, in which case we wouldn't even land on it, or maybe something else that has bolts and screws and a label saying made on exoplanet Y. And we have actually a dating app in the form of the Vera Rubin Observatory that will start operations in a year in Chile. And it will have a camera with 3.2 billion pixels. So this is 1,000 times more pixels than the number of pixels in your cell phone camera. 3.2 billion pixels. And it will survey the entire southern sky every 4 days. So I call it a dating app because it will identify objects like Oumuamua or even smaller ones. I just calculated earlier this week, it could find every week an object the size of a CubeSat in the vicinity of Earth, of the size of these meteors that I was talking about, out to the distance of the moon. So it's a dating app, and most of the time we will swipe to the left and not be interested in whatever objects are found. But every now and then we will see an unusual interstellar object, and we might want to rendezvous with it and take a close-up, high-resolution image of it. The Webb telescope is about 1 million miles away from Earth, and if it looks at the object, it would look at it from a different angle than observatories on Earth. So it's just like having two eyes. You can estimate the distance to the object and figure out the three-dimensional motion of this object very precisely and decide whether there is any propulsion or any other force acting on it in addition to the force of gravity. And, you know, perhaps Oumuamua was a flat, thin object because it was a leaflet carrying a message for our salvation. It would really be tragic if we missed a love letter in our mailbox. I should say that the only worthwhile monuments are those AI astronauts that I was referring to. But when I go to Harvard Square, I see statues and paintings of past deans and presidents of Harvard University, and they were trying to preserve their physical appearance in some form that is static. But within 1 billion years, as I mentioned, the sun will boil off everything on the surface of Earth. These statues would not survive. If you wanted something to outlast the sun, you would send it to interstellar space. And an AI astronaut can carry your guiding principle. It may not be static. It can learn, it can propagate whatever we want to propagate into interstellar space. Now, NASA, when it sent the New Horizons mission towards Pluto, it included a small box that carried 30 grams of the ashes of Clyde Tombaugh, the scientist who discovered Pluto. And I think of this as a very embarrassing fact in our history because these ashes are no different than the ashes of a cigarette. It's basically burnt up DNA. So if an extraterrestrial finds this box, they might wonder, why would the human civilization burn up the genetic information on a scientist that they wanted to commemorate? That makes no sense. That's a primitive ritual. They would want nothing to do with humanity because it sounds like humans are very aggressive and make no sense whatsoever. And just to remind you, this was sent by NASA. So at any event, the Pentagon reported about unidentified objects, and we will hear more about it in a few days. The Galileo project aims to identify the nature of these objects, help the US government, and without any agenda. If we find that these are human-made or natural in origin, so be it. And we developed a suite of instruments that you can see here, basically that they will be taking data of the sky, a video of the sky in the infrared, optical, and radio bands, and in audio. So we're basically filming the sky and getting high quality scientific data because we will understand our instruments. They are fully under control and they are not based on eyewitness testimonies. Humans are not scientific detectors. And we will analyze this data with artificial intelligence algorithms that we already have. So actually, this week, we are starting to collect the data, and hopefully in the coming months, we'll report it in scientific papers. At first, we put these instruments on the roof of the Harvard College Observatory, and now we move them somewhere else, a place that is much better for this purpose. I just wanted to mention another big question that astronomers deal with, which is, what is most of the matter in the universe made of? Turns out that 82% or so of the matter in the universe is of a form that we don't find in the solar system, that is not familiar to us, and we label it dark matter. It's really surprising that cosmologists are getting paid because we don't know what most of the matter in the universe is. My colleagues very often quote Carl Sagan, who said in the 1970s, he said, extraordinary claims require extraordinary evidence. What I say is that extraordinary evidence requires extraordinary funding. Because in search for the dark matter, we invested $10 billion because there were some theorists, scientists, that suggested that the lightest supersymmetric particle, some type of new symmetry in nature that results in a new particle, should have its natural parameter space within the reach of a particle collider. So the Large Hadron Collider was constructed at the cost of $10 billion. We haven't found supersymmetry. And nobody said that it's an extraordinary claim to look for the lightest supersymmetric particle. We just funded it. And of course, it's not a waste of money because we learned that it's not there. But my point is, without the funding, you cannot make progress in science. So claiming that an extraterrestrials is an extraordinary claim, that by itself is quite arrogant because it says we are unique and special. But moreover, in order to find out, we need to fund the search. And if we just invest 1% of the budget of the Large Hadron Collider in an endeavor like the Galileo project, we should be able to address the question of what the unidentified aerial phenomena that the government talks about are all about. Of course, we can search for extraterrestrial civilizations in other ways. We can look for industrial pollution in the atmospheres of other planets, or look for city lights on the night side. I wrote papers on both options. And there is a tension between the ability of a technological civilization to venture into space and its ability to destroy itself. But to answer Fermi's question, it's possible that most of the civilizations that ever existed are dead by now. But the equipment they sent into space, if it's propelled by chemical fuel, is bound by the gravity of the Milky Way galaxy, these objects move at speeds that are at least 10 times smaller than the escape speed from the Milky Way. So the Milky Way is like a basket that collected all of the equipment that was ever launched into interstellar space throughout the history of the Milky Way galaxy. And you can find two types of objects. One would be space trash, objects that are not functional anymore, just like New Horizons will be in 1 billion years. Or you can find AI astronauts. So to find out, we just need to conduct the search. And we have no protocol for how to engage with functional equipment. There is no organization that represents humanity. And we haven't thought about it because we've never imagined the prospects of finding a visitor in our backyard. When we look for radio signals, they come from far away. It takes radio signals tens of thousands of years to traverse the Milky Way galaxy. There is no urgency in responding. But if you do find a visitor, you better decide what to do immediately. My hope is that by finding relics of more intelligent cultures out there, we would be inspired, because if you look at human history, the biggest evil was done by groups of people that felt superior relative to other people. But if there is a smarter kid in our cosmic block, if the technological gap between us and them is huge, then the differences among us humans are meaningless. And we should treat each other as equal members of the human species. And the general message that I would like to convey is that the cosmic play is not about us. We are not at the center of the stage, despite what we prefer to believe for many centuries. And moreover, we just came at the end of the play. The play has been going on for 13.8 billion years. So the play is not about us. If you come at the end of the play and you're not at the center of the stage, it's not about you. And the way to figure out what it's about, given that we don't even know what the stuff that makes most of the universe is maybe to seek other actors, because they had more time to think about it. Thank you. I'll be glad to answer any questions you have.
I just want to encourage everybody to either put questions in the chat box. Maeve and Ed and I are going to try to read them, or if anybody wants to raise their hand and speak directly to Avi, that would be awesome as well. I'm seeing a comment right here that says from Anil. Anil, do you want to ask that question, or you want me to read it?
I can speak to show my enthusiasm for what I heard. So it's very, very, very amazing. But just my question was, this is about consciousness. So how did your consciousness expand enough, or what made you personally be inspired to imagine and seriously believe and put in all your life and sort of be almost a one-man band, reading that there is life out there and sort of interpreting it a certain way and then trying to find that extraordinary evidence?
Yeah, so I had a long career as an astronomer and astrophysicist. I was chair of the Harvard Astronomy Department for 3 terms, 9 years. What brought me to this subject was the fact that Oumuamua appeared to be very unusual. Okay, so it was my profession and the data that astronomers collected on this first interstellar object, because the first object should be typical. You can't imagine something being so weird. And I remember a colleague of mine, after a colloquium at Harvard on Oumuamua, coming out of the room and saying, Oumuamua is so weird, I wish it never existed. And that was an expert working on rocks for the last few decades. So to me, it was actually exactly the opposite. I was intrigued by it. I was, because I pretty much maintained my childhood curiosity. I'm not surrendering to the pressure of pretending to know everything and showing off as if you are an expert on a subject. I want to figure out if there is something unusual. Let's collect more evidence and figure it out. So that's what brought me into this. But actually, a few years ago, both my parents passed away. And I realized how short our life is. So we tend to play these games of impressing others, trying to seek as many likes as possible on social media. And we, rather than seeking the truth, because every now and then, you know, the groupthink is going in the wrong direction. And if you are always seeking approval from others, then you will never, you know, discover something completely new, because people have all kinds of ulterior motives for showing off by claiming that they know everything. You know, the most traumatic experience for me as a kid was to sit at the dinner table and ask a difficult question, and then the adults in the room would basically say, oh, this is not an interesting question, because they did not know the answer to the question. That was obvious to me. And it really bothered me. And I thought that by becoming a scientist, you know, I can rely on evidence rather than on people. Okay, for me, humans are not scientific detectors and are not the way to find the truth, you know. And very often I tell young people that have, I don't subscribe to social media, but I give them the metaphor of seashells, that if you go to the beach and you look at seashells, those that were swept ashore recently, they still have their unique colors and shape. But those that came a long time ago and rubbed against each other for a long time as a result of ocean waves rubbing them back and forth against each other, they break up into indistinguishable grains of sand. And that's what happens when you rub against the views of many other people. If you want to belong to a crowd, or if you pay too much attention to how many likes you have on Twitter. And my advice is to maintain your childhood curiosity, and moreover, think about everything you listen to critically, independently, and decide for yourself. Don't subscribe to a club and then adopt everything that the club says. And so in terms of consciousness, I think the way to be conscious of the reality is to pay attention to the reality and not to what people say about the reality, okay? And we often say that politicians do not pay attention to evidence and are not guided by evidence. We complain about politicians, but my problem is I find it very often within academia. And I can give you one example. This object Oumuamua, okay, that I described, was definitely not a comet of the type that we are familiar with. There was no cometary tail, okay? That's very simple. We didn't see anything. Spitzer Space Telescope didn't find any carbon-based molecules. Okay, that's a fact. Yet, a colleague of mine that is quite nice, he wrote, and he is favorable to alternative interpretations of Oumuamua. He wrote a review paper for the most prestigious journal in astrophysics called Annual Review on Astronomy and Astrophysics about Oumuamua last month, just now. And he writes to me and says, I'm about to finish the review about the comet Oumuamua, and I mentioned the fact that this was a comet throughout the review. So I say to him, how can you call it a comet? It didn't show. It's just like going to the zoo, looking at an elephant and saying that this is a zebra. And so what was his answer? That's interesting to keep in mind. His answer was, I have a theory that in fact there was a cometary tail around Oumuamua when we didn't look at it. So when we looked at it, we couldn't see the cometary tail, but when we were not looking, it had a cometary tail. Just like saying the elephant has stripes when you don't look at it. So let's call it a zebra. And that is the mainstream, okay? To me, that's a misrepresentation of the way science should be done. If you don't see a cometary tail, just say it explicitly, especially at a review paper. It was not a comet of the type that we have seen before. Just say that explicitly. Why try to give this cozy, warm feeling to the crowd that worked on comets? By calling it a comet, then you feel there is nothing unusual about it. And that's not the way science should be conducted, okay? And so my problem is evidence is not guiding even the mainstream within the academic community.
Doctor, can I be heard? This is India. Is anybody hearing me?
Yes, we can hear you. Who are you?
Excellent. A question. I'm in California.
Okay, we cannot see you, but we see TL. Who are
That's
you?
okay. It's a bad hair day, but you can hear me.
Yeah, but who, can you state your name?
Yes, India. My name is India. Really, India. Anyway, but it's in terms of Oumuamua and other objects you've been studying. One of the reasons I was so, and I still am very excited about this presentation, and thank you very much. Dr. Ed Sarath sent the information to me, and we are musical colleagues. And so you talked about identifying these objects also by sound frequency. So I'm curious about the frequency of Oumuamua, and if you have found any predictable markers for these objects that you've been studying, and in terms of the distance from our planet. I know that all planets have their own frequencies, sound frequencies. Could you talk to us a little bit about sound frequency and your research?
Okay, so let me first, as a physicist, let me explain what sound is. Sound are waves created in air. Okay, so just so that you know, air is just above the surface of the Earth. That's the atmosphere of the Earth. If you go to Mars, the atmosphere is very thin. There is almost no atmosphere whatsoever. The moon has no atmosphere. There cannot be any sound on the moon. You can play a record, nobody would hear you. Why? Because there is no medium to carry sound. Okay, light can propagate in vacuum because it's not mediated by a medium. Actually, physicists thought that there is a medium that carries light more than a century ago, and they were wrong. Okay, so there is no medium that carries light. Light propagates in vacuum, but sound is a wave that propagates only in a medium. So it can go in air, it can go in water, but it cannot go in vacuum. Okay, there is no sound in vacuum. So when we deal with very rarefied space, like interstellar space, there is some medium there. It's called the interstellar medium, but it's very rarefied. Nevertheless, there is a sense of sound there. And, you know, nobody put their ears yet to the interstellar medium, but we know that there are, for example, exploding stars that generate shock waves. We see them, and these must sound very loud to whoever is near them, you know. With respect to the interstellar objects that I discovered, you know, if you're talking about the meteors that entered the Earth atmosphere, obviously there was an explosion. It released, for example, the first interstellar meteor released a few percent of the energy of the Hiroshima atomic bomb. Okay, so that was huge. If you were, I'm sure that it was in the middle of the night, but I'm sure people in Papua New Guinea heard a boom. A very loud boom. Just think about an atomic explosion 100 miles away. That's what happened there. This was not a big meteor, just half a meter in size. Bigger meteors generate even bigger explosions. So I would say the sound of a meteor colliding with the Earth atmosphere would be no different than a nuclear explosion if it's bigger than half a meter. Okay.
So my question here then, is it then untrue that a planet, for example, Earth or Pluto or what have you, does not generate a vibrational frequency? Is that correct? I mean, that it might not be audible, but does it mean that it is not generated?
Well, it can generate in the medium that surrounds the object. So actually, the only medium that exists in between the planets is the solar wind. The sun sends out a wind of particles that are emanating from the corona of the sun. They, you know, the sun is surrounded by a very hot halo of hot gas, 1 million degrees or so. And that gas is driving, the sun is evaporating, losing mass at a very slow rate. But every star is losing mass, and the sun would lose, in principle, just 1% of its mass during its lifetime. So it's really a very small amount of mass. But nevertheless, this wind that comes off the sun is going through the solar system. Okay, so it's passing Earth, and it's also passing all the other planets. So in that wind coming from the sun, as the planet move in that wind, they do generate some sounds, but it's at a very low frequency. It's at the frequency of associated with the period of these planets around the sun. So, you know, we can, I mean, obviously it's too low frequency. By the way, a comment about sound, because we are in the Galileo project trying to record the objects, the unidentified aerial phenomena as well in audio, okay? And turns out, so we are going to very low frequencies. It's called infrasound, very low frequencies that the human ear cannot listen to, and very high frequencies that are called ultrasound. It turns out that the human ear is perfectly designed, probably by Darwinian evolution, because very high frequencies of sound get absorbed in the air. By the viscosity of the air, the high frequency does not allow them to travel significant distances. So it wouldn't really help us, the human ear, if it were to listen to high frequencies, because they would not come to us from large enough distances to warn us about a threat. Like if a lion comes to eat us, you know, it doesn't really matter if that lion generates high frequency sound, because it can only go across, you know, once we realize the lion is here at high frequencies, it's already eating us. And then at very low frequencies, there is not much information because the wavelength of the sound is very long. So, so it's sort of the optimal range of frequencies that the human ear is sensitive for, that helps us in terms of survival, helped us in the past. And that's why we can hear those sounds. So if you think of all of music that was developed by humanity, it was designed around this range of frequencies that the human ear is sensitive to, which was by itself selected by Darwinian evolution. Just think about it. So it's all going back to biology and survival in nature, because we have ears so that they can alert us to dangers, to threats in the jungle or wherever humans lived. So the ones that didn't have ears were eaten up and didn't survive. Those that had ears are the ones that survived, that we are the descendants of.
Thank
I
you.
want to make sure that we give some other people an opportunity to ask
Yes.
questions.
Yes,
TL, your hand has been up, so I'd love
Yes.
to hear from you.
yes, I have a pointed question. First, I'd like to praise Professor Loeb and Professor Serif for having such a fine show. My first question is, Dr. Loeb, have you been privy to viewing any of the Tic Tac videos that were filmed off the coast of California prior to 2017 that we've seen for the last 5 years? And my main question is, are you privy to any close-up photographing of those objects, and do they suggest to your mind a structured nuts and bolts craft of some sort, not made by human hands? Go ahead, answer.
Right. So the TikTok videos, they are 20 years. Well, there are the more recent videos that were leaked and from the Department of Defense. I haven't seen anything beyond the publicly available data. There were eyewitness testimonies, and I met one of the pilots just 2 days ago, Alex Dietrich, that reported about the Nimitz incident. But I haven't seen anything beyond the publicly available videos and data. And those data are not very convincing, I should say, from a scientific point of view. And that's why we have the Galileo project, because instead of waiting for the government to declassify data, a much better approach is to collect our own data. And because the sky is not classified, the reason that the government has a lot of classified data is because the sensors that collected that data are classified. The government doesn't want adversaries to be aware of the capabilities of missile warning systems that the US has. And so if we collect new data that is open, using instruments that are off the shelf, that would be the way to figure out the nature of these objects in a transparent and peer-reviewed way, the scientific method way. And that's what we aim to do in the Galileo project. I don't want to look at classified data because that will tie my hands. I will have to sign a legal document, an NDA, and then I will not be able to do my science in a transparent way. So a much better approach is, there is this play by Samuel Beckett, Waiting for Godot. Waiting for the government to declassify is like waiting for Godot. You can wait forever. It's much better to get your own data.
Thank you.
I see, Stephen, you have a question. Would you like to speak?
I think you are muted, Stephen.
Yes, you need to unmute yourself.
Thank you, Dr. Loeb. Considering the last question, what do you think of the proposal of simply charting deviation from natural behavior of the object as the criterion for whether there's intelligence behind it or not? I say that because we recently had a NASA vehicle that crashed into a meteor and caused it to deviate. But you haven't seen any of that kind of behavior with the Moa. Seems to me that would be a simple criterion.
Well, you have to keep in mind that interstellar objects like Oumuamua, they move faster than our chemical rockets. So it was impossible for any existing spacecraft to chase Oumuamua and not to speak crash with it unless you identify it on its path towards us, and then you meet it along its path. But we got the alert about Oumuamua. We discovered it when it was already moving away from Earth, so there was no way to chase it. So really, the key would be to rendezvous with the next Oumuamua by finding it before its approach towards us, and then you don't need actually to fly very fast. So that would be possible. And by the way, the NASA mission DART was aimed at demonstrating that we can deflect the trajectory of dangerous asteroids, objects that may collide with Earth, because we know that the dinosaurs 66 million years ago were killed by an object the size of Manhattan Island, the rock that collided with Earth. And we think that our brain allows us to avoid the catastrophe of this type. So we don't need the huge bodies of the dinosaurs. The brain is much more important. So we can build telescopes that would alert us, like the Pan-STARRS telescope. That was the rationale for building it, that will survey the sky and search for objects, and then we can deflect them. So NASA wanted to demonstrate that by crashing something onto an asteroid, you can deflect it. That was the whole purpose. But in the future, we just want to find more interstellar objects, and that's what the Vera Rubin Observatory will do in a year. So that will increase our collection of possible objects to get more information on.
One sub-question of what you just mentioned is that you could look for whether the object deviates from natural behavior on its own.
Right.
Yeah. Moa hasn't revealed that kind of deviation so far.
Well, no, there was a deviation from a path shaped just by the force of gravity, and there was no cometary tail. So that's, but you're right that there wasn't any direct signature for, a propulsion system. And it could be, that most of the objects we find that are, even if they are technological, they are, just like I said, space trash. They are not functional anymore. It's possible, but we don't really know, because it could be that we don't understand the purpose of the object. And it's, for just to give you an example, it could have been a mothership that released sort of a lot of small crafts, much smaller, that we can't see by the reflection of sunlight, just like dandelion seeds that, are carried by the wind. And those small CubeSats were released close to the habitable planet. So maybe, they got closer to Earth and we didn't notice that. So we never, we should never assume anything. We should just collect as much data as we can. That's the point. And the problem is that when you are not willing to allow the discovery of something like that, when you say that, we shouldn't even search, And by the way, it applies also to an expedition of the type that I described, that we are fully funded by people who are excited by the mission of this expedition. We're not taking away any money from other science projects. And nevertheless, some scientists had an issue with us going to look for the fragments from this meteor. And my point is, even if it's natural in origin, we would learn something new, because it's the first time that humanity puts its hands on an object that came from outside the solar system.
Thank you.
There was an interesting question earlier about what kinds of contributions archaeologists and archaeological disciplines might have with looking at relics of the interstellar origins. I'm wondering if you have any comments on that.
Well, the question is, how do we identify that it's interstellar? So the best way to do that is by the speed of the object that shows that it was not bound to the sun. But when you look at archaeology, you just find an object, you don't know how fast it was moving when it crashed to Earth, even if it's a meteor, an ancient meteor. So unfortunately, most of the rocks, the space rocks that collide with the Earth are from the solar system. So only 1 in 1,000, based on our statistics, comes from interstellar space. So you have to go through 1,000 meteors before you find one of them that is interstellar, and it's not an easy task.
Mm-hmm. We probably should finish up quickly. I know Xander had a comment. Xander, if you wanted to say your comment. And also I noticed that there is a rabbi on the call tonight.
Oh yeah,
and I'm wondering if that is the same rabbi.
Yeah, it is the same. It is the same.
It's the same. And if he wanted to introduce himself in person, we would love to have that happen. So perhaps
go ahead.
Go right ahead.
Yes, hi, I'm Rabbi Rob Dobberson from here in Ann Arbor, and I did give a sermon on the subject a year or so ago, and been in contact with Abi. It's very nice to meet you this way, and very excited about this the whole subject. It's been a subject I've always been interested in, and was just thrilled to read the book and thrilled to be involved in this discussion.
Thank you so much for your email from a year ago and the sermon as well. I mean, I learned from it more than you learned from my book, probably.
I don't know about that, but thank you for your kind words, and I'm very excited about your presentation. This entire subject has some spiritual has a spiritual side as well as a scientific side.
That's what I'm discussing in my next book to come out in June next year. So check it out.
I will.
Because its primary focus would be on the implications for humanity.
Mm-hmm.
Yeah.
Thank you.
Speaking of the implications for,
I was
sorry.
going to ask you, I was going to say, Maeve, will you read us some of the questions that I think I've lost a few?
Yes. Oh, no worries. So speaking of the implications for humanity, this will probably be fun to answer. Xander asks, do you worry about what the outcome will be of direct contact with intelligent extraterrestrial life? Where do you think we fit on the scale of progression? In other words, should we be worried about poking around with something we don't know about?
Yeah. So, we developed our science and technology only over the past century, and that's a very brief amount of time. It's 1 part in 100 million of the age of the Earth or so. And so if you think of this, you realize that the chance of them being exactly at the same technological phase as we are is really small. Okay, so there are 2 possibilities. Either another civilization is much more primitive than we are, or it's much more advanced than we are, because it's very unlikely for them to be exactly at the same phase. And the point is, if they're much more primitive, we'll have to build a spacecraft that will go to their planet, and then we have to land on the planet and start searching through the trees to find them, because that's what we did 1 million years ago. We were in the jungle, we weren't that easy to find, and that's a lot of work. Frankly, I don't think it's very feasible. I wouldn't do that. But if they are much more advanced than we are, the other option, we don't need to do much, because they will come to us, okay? And if they do, there will be a huge technological gap between us and them. So we could still find evidence for equipment. We would see that it's not natural, it's not birds, it's not bugs, it's not a thunderstorm, it's a real object. It's also not human-made because it's doing things that we can't do with our gadgets. But what it does do and what it means and what it aims to, what it's seeking may take a while for us to figure out. And it may well be that we will need our AI systems to figure out what their AI systems are doing, because they will have better kinship, AI to AI. You know, there was a very important philosopher, Martin Buber, a Jewish philosopher, who talked about two kinds of relationships a century ago. He was talking about the I-it, the interaction between a human and an object, and the I-you interaction, the interaction between two humans or the human and God. But one thing he was not aware of is the possibility of artificial intelligence, because that's a completely new interaction. So we are entering now a new era where there will be a human AI interaction. We are already living in it. You know, when you're doing a Google search, you're already using that. And when you're there are self-driving cars and so forth. But there would also be an AI interaction. And that's the one. So once AI systems become sentient, we are all embarking on a completely new territory, because they will start interacting with each other. And, you know, they might feel kinship to extraterrestrial AI systems.
Lovely. Another comment from one of the people watching, Stephen Modell asks, how do you consider the possibility that the universe becomes more sophisticated in evolution as time moves along, and that late evolution, humans on Earth, may have benefited from earlier trials in the evolution of intelligent species?
Yeah, so indeed, there is this property of the universe that it started very simple. It was basically a nearly uniform mix of the fundamental particles that make up nature, and they were very hot early on after the Big Bang, and then out of the small inhomogeneities or the small differences in the density of matter grew the galaxies and the stars that we have now, and life on Earth. And Earth is just leftover from the formation of the sun. It's you know, there were rocks that were formed out of the disk that surrounded the sun after it was made. So at any event, indeed, complexity was not there to start with. There was no life early on in the universe. Life came only after stars formed and created the heavy elements that we are using for life as we know it. And I think the reason that as the universe progresses, things become more complex is that the universe started simple. If the universe started complex to start with, then, you know, it could have been very different later on. So, you know, like, we are obviously complex systems, and you see, if you look at world politics, it's possible that there would be a nuclear war and that we would wipe ourselves off the surface of this planet. You know, that's a possibility. And then, of course, Earth will come back to its simpler form. So you can imagine circumstances where out of complexity comes simplicity. If humans are not smart enough to preserve our civilization, then Earth will return to being simple. Just keep that in mind.
I think that's a pretty interesting way, an encouraging way for us to end our evening, unless we have any other questions. Ed, and you wanted to possibly make some closing statements. I just have to thank you so much for giving us so much time, so much good information, and for your warmth, which really comes through on the screen. It gets all of us excited about thinking in new directions, and I know I really appreciate it.
Thank
Ed,
you.
did you have any closing comments?
Yeah, thanks, Molly. And just, you know, I want to thank Dr. Loeb, and also I'm looking through the list of attendees. Thank you again for participating. And I'm so impressed that we have faculty from across fields. We have community members. We have, I'm very impressed. We have our jazz students are fairly well represented, with actually a couple of good questions that we didn't get to in the chat. I'm very proud of you guys. And what I want to do on our campus, and actually we have a national network that we're forming related to creativity and consciousness, but I want to make, in fact, Avi might recall a conversation we had this in our first context, in which we have, there's going to be 7 pillars, but one of it is going to be dealing with extraterrestrial issues and potentialities. But I'd like to have a group on our campus that is devoted to this. And so people can reach out to me and we can, we can pursue that. But thank you so much, Dr. Loeb. It's so inspiring. And, I have a feeling of, we have probably 3 or 4 talks a year, but this is one that has definitely has a commentary, a commentary trail, you might say, that's going to not dissipate, but not because it's because this is actually advanced intelligence. So it's probably not the greatest metaphor there, but there's something there that's at least a bit coherent. But thank you so much, and we'll I look forward to keeping in touch.
Thank you. Bye-bye.